Look, let's just jump right into this. If you've spent any time in the engineering trenches, you have absolutely lived this nightmare. You wrap up a complex feature, you feel great about it, you push your code, open the pull request, and then you just sit there. You wait. You're staring at this broken, incredibly noisy, agonizingly slow cicd pipeline. 20 minutes slowly tick by, and then boom, the build goes red. It failed. And why? Because of a missing semicolon, or maybe an unused import, or just some random trailing white space. So you fix it, push it again, and guess what? You wait another 20 minutes. It is just pure, raw engineering frustration, right? We are literally wasting countless hours just sitting around waiting for completely avoidable failures to surface. Which really begs the question, why is this still happening? I mean, think about it. We pour massive amounts of money and engineering effort into these robust cloud infrastructures, dedicated runners, and super complex deployment pipelines. So why do they constantly break down on the simplest things? Honestly, speaking from real production experience here, it fundamentally comes down to an architectural flaw. Most teams are relying entirely on the CI pipeline as their absolute first line of defense. And if that CI server is the literal first time your code is ever evaluated for correctness or formatting or security, well, you're going to discover those silly, simple errors way too late, usually deep inside that massive 20-minute run, or even worse, right before you hit production. You see, that old way of doing things kind of treats the CI server like a giant garbage disposal. You just chuck whatever you have in there and hope it magically filters out all the bad stuff. But there's actually this hidden layer of optimizations out there. And honestly, the best part about it costs exactly $0. The real DevOps way is all about catching these failures locally, right there on the developer's machine, long before a commit is even pushed up to the shared repository. Now, the core philosophy driving this whole hidden layer is something called shift left. You've probably heard the buzzword thrown around, but practically speaking, it just means moving your failure detection way earlier in the development lifecycle. Think of your software development process like a physical factory assembly line. Back in the day, we put all of our quality assurance inspectors at the very end of the conveyor belt, meaning if a product was defective right at step 1, it still traveled the entire length of the factory floor before anyone even noticed. What a massive waste of time and resources, right? Shifting left means we take those QA inspectors and we put them right at the very start of the belt. We catch the defect when it is incredibly cheap and incredibly fast to actually fix. So how do we actually build this? Well, our very first line of defense is what we call the pre-commit validation layer. Basically, before code even attempts to leave a developer's laptop, we install these automated bouncers. These are local Git hooks. And depending on your specific ecosystem, you might be using the Python pre-commit framework, or maybe Husky if you live in the JavaScript world, or even Lefthook if you want really fast multi-language orchestration. The second a developer types git commit, these tools automatically intercept that auction. If the code isn't up to standard, boom, the commit is instantly rejected. So that excruciating 20-minute failure loop, it's instantly reduced to a fraction of a second. And the very first thing these automated bouncers should be doing is removing style noise. Seriously, have you ever been stuck in one of those code reviews where two engineers are just endlessly arguing over tabs versus spaces, or where a line break should go? It is such a massive, exhausting drain on everyone's productivity. By throwing in tools like Prettier, or Black for Python, or GoFMT, we entirely eliminate those petty arguments. The code gets auto-formatted to a standardized shape before the commit is even actually created. It all just happens completely in the background. There's actually this brilliant quote straight out of the Black documentation that captures the exact engineering mindset we're going for here. It says, "You will save time and mental energy for more important matters." And that just hits the nail on the head. By automating the exact boring minutia of hand formatting, you instantly speed up your code reviews. Why? Because the reviewer is only looking at the actual logic changes, not the syntax shaping. You get these nice small diffs, and most importantly, you totally prevent the CI pipeline from blowing up just because somebody missed a single space. But look, formatting is really just the cosmetic layer, right? We need to go deeper into structural code defenses, which brings us right into linting. Think of this layer as an automated, highly aggressive spell checker for your software architecture. We're talking about tools like ESLint or Golang CILint that instantly flag unused imports, syntax errors, and really suspicious constructs. They aren't just there to make the code pretty. They are essentially mathematically proving that certain classes of bugs absolutely do not exist in your code base, all before you ever even try to build it. And I have to say, the speed of modern tooling in this space right now is just staggering. Take modern linters like Rough in the Python ecosystem. It's written in Rust, and it can literally be 150 to 200 times faster than older alternatives like Flake8.
I mean, we're talking about scanning an entire massive enterprise repository in less than a single second. When your feedback loop is that instantaneous, developers actually enjoy using it. It doesn't disrupt their flow state at all. It genuinely enhances it.
When you kind of zoom out and look at it all, you realize this isn't just some random shopping list of tools. It's a completely mature plug-and-play ecosystem. Whether you're using Husky, Pre-Commit, or Left-Hook to orchestrate things locally, they all just seamlessly plug right in to formatters like Black or GoFM, linters like ESLint, and even security scanners. Honestly, the specific tool you pick doesn't matter nearly as much as the architectural decision to actually build this local layer. They work agnostically across your entire engineering team to forcefully ensure correctness right out of the gate.
Now, to pull this off, it does require a real cultural shift. Nobody has a higher priority task than fixing the build. Because, if the mainline is broken, everything just completely stops. By catching these issues locally, we protect that mainline. We keep it absolutely pristine. Real quick before we move on to the next layer of this system, if you're enjoying this explainer and finding this deep dive valuable, consider liking the explainer and subscribing to DevOps Corner for more system design and infrastructure content.
Okay, so we've got the code formatted and we've linted it. Awesome. But what about the really dangerous stuff? What about those digital skeletons in the closet? Let's go ahead and shift our analogy from that factory assembly line over to a high-security airport checkpoint. Just think about that incredibly tired developer working at 2 a.m. How do we prevent them from accidentally pushing their AWS credentials or a database password or live API keys directly into a shared, potentially public codebase? Well, we apply that exact same shift-left mindset straight to security. We embed secret scanners to act as invisible tripwires. The exact millisecond that tired developer attempts to commit a file, these security checkpoints wake up and hunt for credentials. It frames security as a shared responsibility, and it's just baked right into the natural workflow automatically without ever requiring the developer to go out and learn some massive, clunky new security suite. And the best part is, these aren't just dumb keyword searches anymore. Tools like TruffleHog and GitLeaks use this really smart combination of complex regular expressions and entropy analysis to find hundreds of different secret types. But the real magic here is the live validation. TruffleHog doesn't just look at a string and say, hey, this kind of looks like a token. No, it actually reaches out to the provider and asks, hey, is this credential active right now? Meanwhile, tools like Snake and Dependabot are shifting left on your dependencies, catching vulnerabilities way before they are permanently baked into your software supply chain. So you might be wondering, what actually happens to your CI/CD pipeline once you have this incredible local layer humming along? Well, this is the massive paradigm shift. Your CI pipelines, whether you're running GitHub Actions, CircleCI, GitLab CI, or BuildKite, fundamentally change their entire purpose. CI becomes all about orchestration, not basic validation. Your expensive cloud runners are absolutely no longer wasting compute cycles, failing on a missing comma or an exposed API key. They are finally freed up to do the real heavy lifting, complex integration testing, building container images, and deploying infrastructure. And because your CI pipeline isn't constantly getting bogged down by trivial failures anymore, it becomes blindingly fast. When you combine this perfectly clean upstream code with modern CI optimizations like Docker layer caching or monorepo build systems like NX and TurboRepo, you get a massive productivity multiplier. When developers know for a fact that the pipeline is fast and reliable, they naturally start deploying smaller changes, much more frequently and with significantly lower risk. It's a total game changer. Let's step back for a second and really look at the whole system we're building here. Because this isn't just a collection of random developer tools duct taped together. It is one unified, highly engineered delivery system. You start off with local validation, passing code right through formatting and linting filters, dragging it across those security tripwires, and only then, once it is mathematically and structurally completely sound, does it actually enter the fast CI pipeline. All of these disparate practices perfectly merge to catch failures when they cost literally nothing but a fraction of a second to fix. And honestly, that leaves us with this final definitive engineering truth. You can go out and spend millions of dollars on premium cloud infrastructure, but the absolute best CI/CD system is the one where failures are caught before CI even starts. By shifting left and leveraging the $0 optimization layer, you're building a real culture of speed, quality, and security that just works automatically in the background. Which really begs the ultimate question for your own engineering team. Are you still paying cloud providers to find your missing semicolons, or are you finally ready to catch failures when they cost absolutely nothing? If you found this explainer helpful, make sure to like and subscribe to DevOps Corner for more deep dives just like this.